All right. So class agenda for today is pretty quick. We're going to start with any questions that you guys have over assignment 3 to begin with, then the kind of final model object submission or data set. If you don't have any questions over that right now, that's fine. You can always ping me offline. Again, these aren't due until next Monday, so a little weird. Today is our last day in class, and so we're going to do the exam at the end of class today. I'm going to make that the second half of the class. I don't think it's going to take you anywhere close to an hour, but we'll just let out early. It'll be your last day of class and get out a little early. So we're going to do that at the second half of the class. So we just have part 1 and part 2 today. So we'll cover, if you have any exam questions or any just like topical questions about the course, we'll hit all of those in the beginning section. You're good. I gotcha. So we'll hit all of those in the beginning section here. And then if there's time, so if we cover every question that you guys have, we're just going to switch to open-ended questions in general. Hold on. I have one part and sorry. Make myself a note there. So open-ended questions in general. So any questions you have about machine learning or modeling, just anything that's come up throughout the course that you want to talk about or things you were hoping that we were going to talk about, maybe we didn't cover. I think I got some feedback last time that the whiteboarding session went maybe better than looking at real world data sets. So if you have any topics, we can just talk about those and just try to whiteboard them. And then if you don't have anything, then I'll just, ramble about ethical things, proxy features, serving models to production, MLflow, model registries. I'm certain we can fill that hour and a half with any extra topics. So, and then we'll start the exam halfway through, so that would be at 7:30. We'll start the exam at 7:30. Course schedule. So we are now through all of this stuff. I have yet to post 3 lectures, which I'll do after today. It'll be 3 one-hour sections, 1 on deep learning, 1 on NLP, and 1 on unsupervised. But if you want to talk about any of that today, we can definitely can. And we're doing the course exam today. Okay, let's jump in. Assignment 3 questions. Any questions on assignment 3 so far? Okay, that's okay. If you guys haven't looked at it, that's fine. We'll do final modeling object submission. Any questions on that so far? And again, you guys probably all just spent time prepping for the exam. So let's jump to that one. Any topical questions? Yeah.
The first 2 assignments. Are they graded?
They are not graded. I can hand them back though. I can do that while you guys do the exam.
Okay.
That work? Perfect. That'll be a good use of my time. Any other questions? Any exam questions? Or it doesn't have to be exam, just topical questions.
Oh, well, things that you put on the exam topics was the decision trees and the random forest, but I didn't see the video uploaded, so I wasn't able to see.
Did I forget to stream? The video not uploaded?
I didn't see it, but I could be wrong there. I was looking for it yesterday.
There are, I thought I showed you guys the test for a second.
I think that you had said you were going to upload the Jupyter notebook that you were messing with for fraud.
Oh, yeah, I can upload
that. I know I tried to do it in real time with you, but I know I missed things, so I didn't know what things you could.
There are only 4 questions on decision trees on the test, and one of them's not even a decision tree question. There's 3 decision tree questions, and the random forest question, I made a bonus point. And the decision tree is going to be really similar to the example that we did on the board.
Okay.
Let's see, you're looking for,
I do see it. Maybe I was wrong. Maybe the decision tree was more on the board than it was in the actual sharing of
the video?
okay, that makes sense. Any questions about decision trees?
In execution of a decision tree, are you basically passing the object as a class down as you're doing the different features and analysis on it?
That's a good question. The decision tree itself would be an object, and it would have different methods within it. So it'd have a fit method and it'd have a predict method. Inside of that fit method, that is where we're deciding which things to actually predict on. So the decision tree, switch this. Okay, this thing always has one wheel locked. The decision tree, has this class object. And within the decision tree, there's going to be a fit function, and there's going to be a predict function. And when we make an instance, so dt equals dt, when we make an instance, I'll make that a little dt. When we make an instance of the decision tree, our actual tree that exists in that is empty. So if this is dt, and this is our tree, there's no tree in this initially, and then when we call dt.fit, and we're going to pass in our training data. Now the object of this class, so this is our class and this is our object, object instance. Now the object of this class will take this training data and then decide, it'll pass that train data to fit. So this takes train data and it'll return a tree. And then that tree will be, set as an attribute of the class. So once we take in this training data, then it'll say train data. It'll pass this train data to the first node, so to node 1. And in node 1, we're going to decide which feature should we split on within train data. And so it'll do feature split.
So that's also done internally. We don't tell it which features. It says, there's like 4 or 5 different ways you can do it. Entropy,
Yes.
Bayesian, mean squared, a couple others, right?
Yep, you can do impurity, entropy. Entropy is often used, information gain, kind of a derivative of Gini impurity, or Gini index. And then there's probably a ton of other ones that I don't know of. Absolutely. So this part where it's trying to decide which feature do I split on, it has one of those methods that it implements to decide essentially which feature best separates the data, creates the best separation between our targets. So if we had 100% 0 over here and 100% 1 over here, that would be a perfect split feature.
Has anybody ever tried to mix and match, say use a random version? Like the first node you use, entropy, and the second one you use.
Interesting.
Because then you could get a different combination of features as it comes down. Or if you're doing a rainforest, if you did one off of an entropy and another one off of a Bayesian or mean square, something like that, then you can get a different variation of everything across the board. I didn't see anything online about anybody trying.
So are you saying if we had, 1,000 trees and 50% of the trees used one method and 50% of the trees used a different method?
Yeah.
Is that what you're saying? I hadn't heard about that. I'm not saying it doesn't exist. Almost certainly somebody has tried it. I just haven't heard of that and I don't know. I mean, you could easily test it out. So I imagine one of the parameters in sklearn, if I went and looked, is probably how does your tree do its split? So we could create our own. We could make one tree that does a split that way and another tree that does a split that way, and then combine the results. We're kind of abstracting away from the tree predictions at that point. So we're missing if we had.
But in a forest, that might be valuable. I don't know if in a regular decision tree that would be valuable.
Oh, yeah, so that would be the forest method where the trees were building to a forest. Are you saying if we split at like layer 1, depth 1, I'll use proper terminology, if we split at depth 1 with, say, Gini, and then we split at depth 2 with, say, entropy, is that what you're saying? Do different, I don't know.
I don't know if there'd be value in doing that. I don't know.
I'd have to think about that. I don't know. It's a good question. It's a good question. The algorithm that might have the most impact in would be gradient boosted trees, because gradient boosted trees make really short stubby learners. So they're really, really tiny trees. They're just like this. There's very, really, really small trees. So I think that would have a greater difference in the way that the data was separated. Interesting. So all that was to say, no, we're not passing the object to the nodes. We are passing a data set or a subset of the data set to each node. In training, it's a recursive function. In fit, it'll be like a recursive function that'll keep calling itself as we pass down the node to determine those splits. But in predict, it's just straight the data set.
And if you don't determine a depth up front, they'll just go until everything's a leaf node.
It'll go until everything's a leaf node. I believe it has minimum set to 2 by default, but you can change that. So you can change, so that means that it won't make a leaf node of 1. If we get to the end here, and the option is either put 1 record here and 1 record here, it won't do that. It'll just terminate at this node instead with 2 records. I believe the default's 2. That's one of the parameters that you can shift and change, is you can shift how many minimum set of records need to be in a leaf before you decide to classify it as a leaf. And then depth would be another one. So if we say depth can only be 5, even if there's a lot more mixing and separation to resolve, it won't go any deeper. Let me look at at the other parameters of a decision tree while we're at it. See what other ones are interesting to talk about. Yep, so if you go to sklearn tree decision tree classifier, you're going to see exactly what all the things we just talked about, how fitting. So you're going to see criterion. That is one of the parameters that you can pass. I just had a thought on how we could have done your thing. I'll say it in a second. Criterion is a function that measures the quality of the split. That's the terminology that they use. So we talked about Gini, but there's also entropy. Another one that they have here is log loss. So what you could do is you could actually create your own function, and you could make it 50% of the time choose Gini and 50% of the time. So you could just make a wrapper. I don't know if it would work yet to test it out and everything, but you sklearn, that's the one great thing about it, is it totally object oriented. So I've made my own transformer functions before and my own scoring functions. You guys will make your own scoring function in the next class. And so you can make your own function here. So we could wrap our own, it would have to have whatever form. I'd have to see what class Gini, entropy, and log loss are. I'm assuming they're metrics, but so you would just make it a metric class and then wrap Gini in there and wrap entropy in there, and then 50% of the time call one and 50% of the time call the other. It'd be interesting. We could test it out. We could build one, and we could make some performance metric and then see how they perform differently on a large data set.
Yeah.
That'd be cool. I like it. Maybe I'll do that while we're taking the test after I get everything graded. So the next one in there is splitter, best random. So it's a strategy for choosing the split at each node. We, of course, have always used best split. I suppose you could choose random to just select something at random. That's probably more of a baseline thing. So you can know, remember we talked about baseline models. How do you create a baseline model so that you know that your model isn't worse than random, worse than a coin toss? So if you put random in for there, that would probably create random one that you could compare against for a baseline. Min's sample split. So that's the minimum number of samples required to do a split. And then min samples leaf is the one that we just talked about. If there was one at each, it wouldn't allow us to declare these as leaves. Min sample split is the minimum number of samples to split into two nodes. So you can set it. If I have a data set and I only want it to split if there's a lot of impurity to separate. If it's like a pretty good class, then maybe I'll set min sample split equal to 10, and it has to have at least 10 samples to split before it'll do that. Those are max features is also an interesting one. What that does is determine how many of your feature set that you send. So if we have this feature set, we've got 1, 2, 3, 4, 5, 6. How many features do we send? Do we send 2 features? Do we send 4 features? Do we send 5 features? And when I say send features, what I mean is to each tree we train, how many features do we send each tree? And that's what that metric does. So a lot of times, let's see what that's max features. So that's saying send no more than 5 features. You can default, it to send no more than 5 features. But usually it ends up being about approximately half of the data set. And there's a function that sets that too. Max number of leaf nodes. So again, if you're just getting a ton of leaves, you're getting a very bushy tree instead of a really deep tree. You can set that parameter. These are all things that you would search over in a grid search. I can tell you that the most important metrics that have the highest impact generally in random forests to search over our number of estimators. I haven't seen and then max depth. Those are the two biggest ones that I've seen have really big impacts, number of estimators, max depth. And sometimes I'll do min samples at split and min samples at leaf. Those are the biggest impacting ones that I've seen. Okay, that was good. What other topics? And I don't know how to make that thing work. Oh well. I'll continue erasing this, but otherwise I'll fill the time with talking about ethical considerations if you guys are interested. So models are just machines, they're code, and they try to do exactly what they're programmed to do. So if I tell a model that I want it to predict for me the probability that I should offer somebody a loan, basically the probability they're going to default. And so I want to know, given this information about somebody, should I approve them for a home loan or not? And models are not intelligent or considerate in that way. It will achieve that exact objective. Let's say I gave it a performance metric. Given this data, make predictions that maximize, let's say, accuracy, this performance metric. And so that is what it will do. So we have to double check and triple check our models during our model review processes to make sure that they're not making decisions in ways that we didn't intend, that we wouldn't make a decision that way. But again, it's just a machine. So there's an example out of Florida, a bit old. It was some time ago now. Is it because I stepped on this cord? This is why I bring my own adapter. This is the
I'm still live on that.
okay. You can still see the board.
Now you just froze.
Dang it. Is it because I thought I plugged this in. It shouldn't be a computer dead issue. Nope, I got plenty of battery.
There you go. That's
Okay.
I mean,
Can you see the board?
yes.
Okay,
Now it's fine.
good deal. So there's this here we are, bank out of Florida that built a model to make a decision on who to give a loan to. And that's a very common thing, and this was some time ago. And they were very careful. They didn't put in any variables about like gender, about race, about I can't even remember the other ones they might have withheld, but they withhold all these. So there's usually some like protected class variables that you typically don't feed to your model unless you have a really strong business reason why you specifically need that to do some type of protection. And so they were really careful. They didn't put any of those variables in there. They're like, great, we only gave it zip code and some, their income information and all this other stuff. Well, what happened was they got audited by the government, and they found that while they didn't feed any of that information to their model was making very, very bad decisions on who to give loans to based on these segregation lines where certain groups and classes of people lived. And so they actually got in a lot of trouble for that. And the race or the variable that was being used to differentiate on race was actually their zip code. And so there are things in your data set that can be things called proxy variables. It means it represents something about your data. It approximates that, but you don't mean for it to do that. So a lot of times, even after we train a model, you might want to evaluate, if you're a highly regulated industry or just for ethical concerns in general, how your model makes predictions on that data. So if we have our data set, our y equals mx plus b, our beta sub naught plus beta sub 1, x plus beta sub 2, x, then, and let's say this is our x sub 1 is equal to zip code, and let's say x sub 2 is equal to income. And we want to evaluate if this model is biased against our let's just say against gender. Let's see if it makes different predictions for like male versus female. And so what you can do is, given everything is the same, so pass all these variables the same and see if it makes a decision different for your male set versus your female set. So I don't know if that makes sense the way that I said that. Basically, you have, here, let me phrase it this way. We have a data set. Here we go. ID, gender, or some other, ethical attribute that you want to be sensitive to. And it's always good to contact your legal and your compliance department. That's what we do, and they hand us a number of variables that we have to basically scan and check against for the way that our models make decisions. So let's do. What you would do is you would have this other data, your zip and your income, and everybody does really good here. They all make 50K here. So that's just showing that there's maybe no difference between the way that it makes decisions on income, but maybe for all the males, the zip code was 123, and for all the females, the zip code was 456. So what you would do is you would pass this data to your model. You would not pass the gender column because you can only pass to your model, columns it was trained with. And we said, hey, we're really careful. All we used was compliant data. And you pass this to your model, and then you see, what did it predict? And then, maybe it said yes here and no here. And then what you would do is you would compare. Let's compare. How did our model predict against our protected variable? Okay, I'll give you another example. So that's like theoretically how you would do that. And you can see that like this is clearly a biased model. This would be a biased model because there's correlation here between these variable predictions, who gets approved for a loan, and our protected class variable, which is what we don't want to do. So you would probably then go back and take techniques to do that. And let's say, well, that's all the data I have in my data set. It represents the real world. Well, we probably don't want it to do that. So we might make fake data that we might do undersampling or oversampling, and then validate the way that the model makes the prediction so that it aligns with what we would want to happen from a legal and compliance and ethical standpoint. So just be aware of that, even if you're like, I didn't intend for the model to make that decision that way. I didn't give it any of that data. It's just a machine. It's just learning relationships between variables. And sometimes our data can be misrepresented or the data can be biased. And so we have to just be very intentional about that.
I had a question.
Yeah.
So for this company that they intentionally, like, how could they argue that with, like, I'm assuming documentation is the only thing that they can make the argument, like, you know how you can just put on there like what you're doing up for the
Yeah.
data? Is that the only way you can argue like, hey, I didn't mean to, this was purposely done, so then we didn't have that? Or like, how could one make the argument? Because like, one doesn't really know unless they're, like you said, they did not. So I guess, how does one get protected?
That's a good question. I think in these cases, they tend to hold the companies at fault for that and say it was like negligence. So there was a recent case out of Canada. I don't know if you guys saw this one, with a chat bot telling an airline customer that they had a bereavement discount that they could get on their airline. And so they're like, okay, you have a bereavement discount. According to the chatbot, I'm going to go ahead and book this, and then follow the instructions from the chatbot to file for this bereavement discount. And he did that. And then, the company denied his claim. And they said, oh, that's not actually, that was misquoted from the documentation. You should have gone to the website and actually read that information yourself. You shouldn't have trusted our chatbot. And so he took them to a small claims court and he said, nope, this was, he's really making a point because it was just like a $800 flight or something. But he said, no, this was your company, your chatbot that you developed. You should have, made it accurate. It should have, if it told me that I am qualified for this, then I should qualify for it. And the company, in their defense, tried to argue that the chatbot was its own entity, its own being capable of making its own decisions. So that's how companies, an approach they might try to get out of it. The claims court did deny their case and make them pay damages to the individual, like their court costs, and refund their price for the airplane. You do have to be careful, a company, and make sure that you're fitting these regulations and compliance, because typically it's negligence from the company's perspective. But always good to have, so to answer your question, gets to my next point, documentation. So now there's a lot more regulation coming out for the field of AI and machine learning, and it's impacting a lot of things, and big data, not just like large language models and chat GPTs. So like Colorado has some pretty serious regulation on how you have to track which models made which predictions on which data, and what type of model it was, and how that was used in the business. Was it used to approve a claim, for example? This is in the life space. So what most people do now, today, is the same thing, same theoretical approach we take to programming. So when we develop programs, we put all this code in code repositories. So think GitHub, Bitbucket, all those types of things. And we can say this was the version of code that was running at that time. Now the government is asking that we do that with models. So we don't just make a model and it runs on somebody's machine or cluster. Now we have to version our models. And we have to say, this is the version of the model that made the prediction on this data at this point in time, and this is who signed off on it, and this is, so that's something called model registries and model compliance. And the you can look on the internet and find a bunch of companies that have model registries, but if you look under the hood, they all use the exact same tech stack, which I was trying to show, but my screen is not sharing. There we go. Hopefully, I'll try not to step on that cord. It's a wonky deal. So it's called MLflow. And you can just release, I hope I'm not misspeaking. You used to be able to just download this and you could just create your own instance on your computer, but now it's integrated in a lot of technologies. So it's integrated into Databricks, which is a really popular data platform / ML platform right now. And it's integrated into a lot of other technologies. So many companies will sell model registries to register the version of your model. MLflow is what they're using under the hood to do that. So you can also just do it yourself.
What's the difference between that and Git?
That's a great question. So ML Flow is made, let me see if they have let me see if there's a visual. 1 second. I might just whiteboard something because I don't think this is going to have what I'm looking for here. Okay, we're going to switch back to the whiteboard here.
Back onto this real quick, if I could.
Yeah,
Maybe
Back onto
on
this, and then let me write your question off. Dang it. I was supposed to not hit that chord. Okay, hold on. Difference between Git and ML Flow. All right.
So when you're dealing with demographic data, you have a lot of things that can be proxies for different things.
Absolutely.
If you're looking at like what type of a job a person has.
Yeah.
If you're a nurse, 95% of all nurses are women. If you're if you work in that as a street paper, 98% of those are men. I mean,
True.
there's all kinds of proxies you can use out there that can default to identifying gender.
Yeah.
So the job classification may not be, something like that. I mean, that's just one. I mean, you're looking at demographic information with all kinds of things.
Oh, absolutely. So one of the examples I was going to say, it's often that, which is our data just has a higher representation of one class versus another. That doesn't mean it's fair, but that's typically the problem under the hood. And so there was this back in the early days of natural language processing, pre all these large language models. There was, I think it was Google, trained a model to go through resumes. Sometimes you open up a job and there will be 500 applicants, and it's a lot of work for HR. So they trained something to go through those resumes and predict if they're a qualified candidate or not, whether they should interview them. And they found that similar to this methodology for evaluation against bias, they applied this methodology with gender again, passed 2 resumes, exactly the same, word for word, down to their experience and job experience, copy paste. All they did was change the name from a female name to a male name, and it recommended that they should interview the male one and not the female one. So yes, and that is not because the model was, a bad model or making bad decisions, or that the male candidate was really more qualified. Clearly, they weren't. It was the exact same resume. However, more of their data had males in it because it was the tech field, it was the tech industry. It's overrepresented by male individuals, and so they had to go in and fix that and adjust the model. So that is, I would encourage you to look to solve that problem. I would encourage you to look at what are you trying to predict? What are you trying to do with this information? What's the outcome that you're trying to achieve? And what are instances in which that outcome would be unfair, or maybe it's not even the outcome you want, such as the resume one, having 2 resumes the same, changing one arbitrary attribute such as name.
What would be the equivalent to zip code? Because I don't know how you would even define that. I'm just trying to think what could have been used as a substitute for zip code if you were to do this. Because I can't think of you're thinking where we're at in Nebraska, a lot of the schools are segregated to begin with. So zip code, you can say just North Omaha, or there's a overpopulated amount of a very congested number in the population of that. Just so I was trying to figure out we couldn't do neighborhoods, or you know what I mean? So
what you want to make sure is it's okay to use zip code. I think that's okay. What you want to make sure is that if you pass every other variable, every other instance about your person, their job title, what their income is, how long they've had that job, how long they've lived at their current residence, if everything else is the same and all you change is the zip code, your model's probably making a biased decision there. It probably shouldn't have that. I don't know that is ethical or the outcome that compliance or legal or regulatory would want in that situation. If, you know, you're all data scientists and you all make $120,000 a year and you've all lived at your house for 7 years, just because you live in a different zip code, is that ethical to make different decisions for you on whether or not you'd be approved for a home loan? Probably not. I mean, maybe. I'm not a home loan approver, so I don't know. Perhaps. I'd ask legal and compliance. I can tell you, there are situations, we don't always just want to extrapolate from the protected class variables. There are situations where those do have meaning in the data set, and it is important and it's ethical to include them. So I work in claims, and a lot of times we get maternity claims. And so for certain types of claims, women are out longer than men for leave of absence related to maternity. So when I'm looking at disability duration and they're working with nurse case managers, if they have certain diagnoses, there are different presentations, representations, and durations of that from a medical perspective for female versus male. So we actually don't want to abstract that attribute out, because from a medical perspective, it's very significant and it is important. So that is one where we do include gender in that case. So there are reasons to include it, but it's all about like meeting regulatory requirements. So anytime we do include PII, so if we do include gender, anything else like that, it has to be logged and reported in a different way. So we have a special set of models that are all PII models, and they have more review, more rigorous like attention to them to making sure we're not misusing them.
Would you then, if you're trying to figure out, once you identify that you have a bias, would you then try to go through your entire model, do a fit minus one feature at a time, and to figure out what is causing your bias? Or
Yeah. I would compare, yes, that's a good point. I would go, there's a couple different ways you could do it. You could see if there is correlation. You could run a quick correlation metric, quick correlation matrix to your other variables, see if there was just variables that moved and flowed together. Or you could go through and predict this Y output for one at a time. So you could say Y hat is equal to hold everything still, everything constant, except B sub 1. Change that and see what's the output. Oh, that doesn't make sense. That's our intercept. B sub 2. Y hat, hold everything constant except B sub 3. Hold everything constant except B sub 4.
so you just do that by doing something with a loop, and if you want to capture the results.
Yep, and then compare these predictions. I guess there's a couple things you could do. You could ask yourself, does that make sense? So does it make sense for Y hat to change that much based on zip code if everything else is the same? Or does it make sense for Y hat to change that much on income if everything else is the same? Well, income probably, that makes a big difference for home loans in what you can afford. And yeah, then you could compare that also to your protected class attribute. What all of your Y hats were compared to this. If there was
more stuff, do you deal with like thousands of rows, hundreds of thousands of rows, millions of rows?
Millions of rows. I mean, it depends, but in general, we have like 1.8 million claim records, and then depends on our use case that we're applying that to.
One question back to the model register.
Yeah.
Say you do this, and let's just say that there's no bias registered, and then something happened where you re-looked at your stuff and say, wait, hold up, we did mess up. We need to relook at this, but you've already registered that model. Could one, like, I don't know, like could you amend, I don't know what the right word.
Absolutely.
And then if so, does that look suspicious that you did the amended, or is it more like?
You hit the nail on the head in the power of ML flow, and
Okay.
exactly why everybody likes that so much. So, sorry. This is like kind of hard to wipe off at times.
I think if you do it the other way, you flip it, it should,
It's easier?
yeah, I think that's how it stuck yesterday.
Oh, I'm gonna flip it.
Not yesterday, Monday.
Hold on, we're gonna get this rest of this erased. Be a good citizen, not leave this for somebody else.
I can look that up myself.
Okay, no, I think I'm gonna hit that here in the same question. So the questions will be the same. There we go. Hey. Okay, so the beauty of ML flow is let's see ML flow. ML flow has two. I'm trying to think of how to organize this. Hold on. Okay, it has three functions. One is experimentation. No, three features that people like a lot. The other is a model registry. And the other is model serving. And in general, there's actually something called the ML ops lifecycle. ML ops. I'll see if I can find a picture. It's really, really interesting. But it describes basically the operational development and experimentation of your model that kind of goes in this circle. And then this operational perspective, which is what you said, where we serve a model, but occasionally we need to train and update and push a new model. Okay. So the difference with ML Flow started as an experimentation platform. This is its origin story back, I don't know, maybe like 2018, about time frame, 2013 to 2018. It was an experimentation problem. So when we build models, you'll notice that a lot of times we'll build models and we'll have like a depth of the tree, and we'll have n estimators, and we'll have let's see, n estimators. What's one more? We did min split at node. So let's say min split. So you have all these what are called hyperparameters for our tree that we're training over. And then we'll have all these evaluation metrics too. Maybe when we want to look at F1, but we want to look at accuracy, but we also want to look at the rock score. And maybe we also want to look at, like, that's for the random forest. And then maybe we also want to look at a neural net and all these other different type of models. So they have this experimentation platform where you can run your grid search and it will log for all of your runs. Here was your depth. Your depth was 1, 2, 3, 1,000 here, 500, 6, 7, 7. And this was your there we go. This was your F1 score, your accuracy, your rock score across all of these different runs. And the reason why this is nice is because, so it used to be that these models would take a really long time to train, so hours and hours and hours. And then you'd have it train, and then you'd walk away, and then your notebook would die, and then you'd come back, and you'd be like, I have to rerun my model. Oh no. And so it logged all these metrics for you. Not only did it do that, at the end of the run, it found the best one, and your code would find the best one, and then it would log this model object, which is maybe like a .pickle file or a .joblib. I'm not sure which one. You can use either. Lib. So it would actually load that model object. So then as you did this run and you were like, oh, actually I want to try a neural network instead, and I want to train it to do this, and oh no, my metrics dropped. I want to go back to that other model that I trained. I tried all these different experiments, because that's what you do a lot, is you try all these things, and sometimes you go down a rabbit hole and you're like, oh, this is actually way, way, way worse than what I was trying before. I need to go back 10 steps ago to the experiment I had before, but I don't really remember what parameters I trained it over, and I don't have the object anymore. You can just grab that exact object and it'll tell you what the parameters were that you trained it over. So this is kind of where it started. Now it's super, super cool. They have this function called, you used to have to manually tell it what you want it to log. They have this function now called autolog, and all you said is autolog is true in a Databricks environment, for example. And it'll just, if it's an sklearn model, it understands the object-oriented structure of the sklearn models, and it'll automatically log all this for you. You have to tell it what to do. It just does it. It's pretty cool. So that's experimentation. So that's really important because it helps us track what experiments had what kind of performance. And I wish I had my work computer here. I'd show you what the dashboard looks like, but it'll make all these model dashboards for you without you even having to do it. So it's got a lot of out-of-the-box features. The second piece in MLflow is this model registry. So it's related to this model object thing, but it's more about which are actually being used kind of in production. So once I'm ready to deploy something to production, how do I save that model object? And so the model registry is different from Bitbucket because the model registry actually saves this object file. So, or GitHub, it'll save a joblib object. So it's not saving source code. Your source code would still, that you use to build the model, would still be saved on GitHub, but it's saving this actual joblib object in the repository, and really it's just a bunch of JSON metadata about the model. You can put in whatever you want in there. So we might have hey, this model uses PII data. So you log your model object. To get to your question about what if you need a new one, the powerful part of the MLflow model registry is that these are permanent. So you cannot change them. So I can't come in and say, oh, just kidding, I didn't do that with my model. Don't look at this. I did something else. So from a legal and compliance perspective, it's really secure. What you can do, though, really easily is just say, oh, that was V1. Here's V2. And so it basically says, it will archive this so it still exists from a historical perspective, but then it'll give you V2 is your new updated model. Then it has this really powerful function called model serving, and it will automatically, I'm going to sell you guys on MLflow, I feel like a spokesperson, it'll automatically stand up an API interface for you. And so I can just, at any time, pass a JSON payload to this, which, sorry if that doesn't mean anything, I can pass a JSON payload to this, and it'll give me a prediction, which is pretty darn cool. So it used to be that you would build this model, and then you'd have to put it in a bunch of Python code, and then you'd have to wrap this in a function, and then you'd have to put it on a server, and then you'd have to serve it, and it's just a lot of infrastructure. Now I can just say, oh, model registry, here's my current model. I'd like to serve this to prediction, and it says serve this to production. It says, here's your API. You can hand this to anybody internally within your private cloud to hit this API.
Is this an on-prem or is this a SaaS or?
This, so the model serving piece I was speaking to specifically was a Databricks, is integration into Databricks. I'll pull up Databricks.
Oh,
Oh, no, I don't think, we're good. We got lots of time. This is what this session's for, any topics. So this is, I don't know if that's, there we are. So this is Databricks. This is not what it, let's click explore the platform. I don't know, I've never been to their homepage. I don't know what this does. I don't know, they've got a bunch of fancy names, but basically it's like a data warehousing and ML ops platform all in one. So this would be like, for an enterprise, you could have this installed on like a private cloud, or you could just use this yourself personally. I think they have like free versions for people. I don't know if I answered your question.
yeah,
Ish.
because if you're, well, I was thinking, if you're Amazon and you're sending in, the JSON file into the API every 2 seconds, is it an on-prem solution? Is it actually physically an application locally? Or is it something that they're hitting the web themselves, like a web service type of thing to do?
This would be cloud-based. Web service is a good question.
Well, if you're passing a JSON, it's not going to be a web service necessarily, but it could be actually, but I don't know, hopefully not.
I
It's
would
pretty interesting.
I would say there's probably a bunch of different ways you can set it up. Like for us, we do have use the automatic API that gets served from MLflow, but we wrap that in an Azure function and then in an API gateway for security if we're going to expose it externally. So there's definitely like other architectures within that too. And we're a Azure shop, so it kind of depends if you're Azure or AWS or what your platform is there.
If the MLflow account is company-based, does that mean the model?
It's REST API, so it is a web service.
Oh, that's a good question.
Because like, let's say leave.
Yeah.
And like, they could make the argument that you stole,
Oh, yeah. All company property. So technically, anything you develop, but I don't know, companies have different, my company, anything we develop on our company computer is company property. And so any model, anything in MLflow is company enterprise.
The only argument I would say with that is like, what if you had already a mock-up version on your personal, and then you created one on your work thing, and then let's say that you use it for personal reasons, or maybe you got it for job and stuff, and then they can make the argument that that is actually proprietary.
Yes, they can.
Because even though you might have like a way of proving that it was before the date that you actually registered the model to the company.
Once you bring it in internally, it's proprietary. It's company property.
No
I would
matter
say
the-
don't do that
no
if you
matter
don't
the
want.
timestamp.
So you gotta like mark it or whatever.
Yeah, I'd be really careful there. If you have a model that you're like, this is going to change the world and make me $1 million, I wouldn't run it on your company computer.
Because you were talking about archiving the historical piece.
I think technically it would be their intellectual property, and if you continue to use that for other things, you could put yourself at risk of them coming and saying that is private property to the enterprise. Definitely. I'd err on the side of caution.
I was curious.
Yeah, it's a good question. It's a good question.
That's why I kind of mentioned it, blurted it out, but it is a REST API, so it is.
It is
web
REST
service.
API. Okay, so it is a web service.
Yeah.
Yeah. So I wasn't sure there. I don't know what that is. Ambassador program. Maybe I should be an MLflow ambassador. What is that? Oh, look. I can get paid. Funny. Let me see what else I had. I actually had this on here, so I'm glad we talked about it. So I had that as a topic.
Is there people on the stream here? I don't see them.
There. Oh, Missy. Got Missy. Let's
Okay,
see.
good. Okay, so didn't want to lose them.
I missed one. There we are. I think that's the rest. We have 15 minutes. Any other questions, or you guys want to take a short break before the test. Short break. All right, 15-minute break here, and then we'll jump into the exam.
All these agendas, these class agendas, are they
Yeah.
out there somewhere where we have access?
Oh, I can put them out there. Yeah,
This is one of the things that, as I go forward, I'd like to see.
absolutely. That's a great idea. You know, I just made a Google. Oh, you know what? My computer's gonna die. Is this thing not plugged in?
It should be. Maybe.
Maybe it's not.
Somebody's charging his phone.
Which one am I using? Hold on, I gotta follow the. Oh, is this not a?
I don't.
Oh, that's not a charger cord.
I don't
That's
know
why.
what code was this, but this one.
Oh, I think that's what I thought I was using, but I wasn't using that. I'm gonna unplug
This. That
Which one?
This.
this one. There we are. Let's unplug that. Yeah, that was the one I borrowed last time, which I don't know whose that is, but I'll put it back where I found it over by that sink. Sorry, what did you ask me for that? Oh, those documents. So I actually made a Google folder that I started to put this and some of the other things in. So I will share that. There we go. Sorry, I saw last time. I'm gonna get a drink. Yes. right, I just had a moment of inspiration.
You're kicking
Yes, absolutely.
it.
Do tell.
So there's this, I gotta see, I'm just gonna type this on the internet, we'll see what comes up, so bear with me here. Linear models and the XOR problem.
They won't see it.
Oh, oops. Share screen. Oh. That YouTube video might be good. Here we go. Cross-validated Stack Exchange is usually good. Closed. Let me see. Okay, there. I'm trying to find a visual that explains this. It may not. So there's this problem called the XOR problem, which is in computer science and mathematics and many other fields. We try to simplify things down to really, really simple concepts to prove something theoretically. And this was an attempt to prove if there are these labels of these classes for x1 and x2, and I have to go, there's such a better way to explain this, so that's not going to make any sense. But basically, this type of plotting, where this is our class A in yellow, and this type, there's our class B in 0, and we want to train a model to predict on this, can never be fit by a linear model. So there are some types of problems that are a linear model just isn't possible at solving. No matter where we drew a line in here, imagine we're drawing a line here, it won't properly fit the data. If we're drawing it here, it won't properly fit the data. If we draw it halfway across, we have 50% accuracy. If we draw it top down, 50%. No matter where we draw a line, linearly separating these attributes, we just cannot use a linear model to solve that problem. So now I'm going to try to think of this other, what I really want to show you is neural network website where you can add nodes and see output against target data samples. I don't know what the name of this website is. I might have to, I think it's this one. Yep, okay, good. Hey, the internet is a beautiful, beautiful, beautiful thing. I can't believe it found it with that terrible description. So this is really interesting. You can, sorry to dive into neural network divergence here. Basically, this is showing that if we have this X variable that is separated in, let me get to a simpler, here's the XOR problem. Here's the XOR problem. So if we have a data set that's separated like this, and a data set that's separated like this along the X and Y axis, so X1 and X2, what you can do is you can add these neurons, and what it's doing is it's showing you that this is the decision boundary that is identified in this neuron, and this is this one, and this is this one. Remember when I said in neural networks, they're all a bunch of logistic regressions, and that logistic regression is a linear model? You'll notice that all of these boundaries are linear. So in the first layer of a neural network, no matter what neural network it is, your first layer will always be linear. And then let's add a hidden layer here. What this hidden layer is doing, ignore all these lines, but what this hidden layer is doing is it is combining the output from these three in a way that now makes it a non-linear combination. So think of if we have cars and we have the number of wheels on the car and we have the number of seats on the car. Maybe originally, like at one point in the data set, the number of seats are just, it's a really cheap car. But then once you get up to sports car, right, it's 2 seats is like a really expensive car. And so that's a non-linear relationship. and we can't map it with just these linear boundaries. And so we might want to combine those two features, maybe multiply them together, multiply a couple features together to get some other meaningful representation that then feeds into our output neuron. So it's very interesting. So all of this was to say, that the first layer of this network is linear, in that there are some problems that linear regression cannot map. So, such as this one. Linear models cannot solve this problem, but if you, this is actually a really hard one. This will take some time here. We add a bunch of neural layers. What you can do is you can actually train this. So you can hit play, and it'll train a model. And this model is now starting to decide what the decision boundaries are. And maybe I didn't add enough nodes here because this is quite a difficult one, but here we go. It'll start to, let's just give it a couple seconds. This is how many epochs it's ran through, so quite a few here. And this is the test loss and the training loss. Some engineers designed this pretty cool thing. You can show our test data here too, which is neat. So that's the test data, training data. So we'll give it just one more second here, and then we'll stop maybe 100,000 or 1,000. All right, so here is what we ended up with at 1,000. So this is our decision boundary. Anything in the blue is predicted as blue, and anything in the orange is predicted as orange. You can see it's not great, right? It's making some mistakes over here. But what's interesting is you'll notice in this first layer, they're all linear separations. But then when we get to the second layer, we start to get kind of a curved output here. We can start to have some diversity in the way that we represent that. And then we get to this layer, and it's actually representing kind of segments and portions of the photo. And then this is probably maybe the most discernible. Here's the orange layer, and then here's the blue layer. And then it takes those and makes a prediction out with that. So, okay, I don't know if that was useful.
So I can take a meter's history and fill that into that for 6 years and build it. Can we build these ourselves with Python, or how do we learn that one?
I would actually recommend, there are two packages. TensorFlow is probably one of the more popular ones. And then, oh, why am I not thinking of the other one? Hold on. Just click on this real quick. I'm sure once I see it, I'll know it. PyTorch is the other one. These are by far and away, oh, sorry. These are by far and away the two most popular frameworks for building neural networks, PyTorch and TensorFlow. Now, I'll just caveat and say that neural networks are going to require a little more like manual engineering. They're not quite as, that's why I hesitated to touch on them. They're not quite as nice as sklearn, where you just get to import a model object. Originally, sklearn wasn't that nice either. You know, we think back to like 2013, and you had to do a lot of things manually yourself. And eventually they matured and they wrote these functions in there. Unfortunately, the neural network frameworks are now at the point where like the 2013, sklearn and machine learning frameworks were. So you can see that to actually build this model, you literally have to build it yourself in terms of defining your layers, which seems a little archaic. I will say when you build a neural network, your input layers have to match your number of features. So if you have 500 features in your data set, you have to have 500 input layers. And then your output layer has to match what you're trying to predict. So if you're trying to predict two classes, then it has to match that. I'm not totally sure how that works for regression. I can check that out. So it's probably just one node for regression would be my guess. They have great tutorials on TensorFlow. I'm not sure about I'm not as familiar with PyTorch, though it's very popular. So I'd maybe just read about the differences. I'm more familiar with TensorFlow, and they have really good tutorials. Okay, we should probably start our exam, huh? All right, I'm going to stop recording, though I'll still be here or end the stream.